So we are still in 8.3. We're talking about exponential functions. And we have a couple of the application problems left. So it says here we have once an antibiotic is introduced to bacteria, the number of bacteria decreases exponentially. For example, beginning with 1 million bacteria, the amount present T days from the time that this streptomycin is introduced is given by this function. And it says rounding to the nearest 1,000, determine how many bacteria are present after. And so we have 5 days, 1 week, and 3 weeks. So take a look at this function and let's break down the parts of it. So I have this A of t, that's function notation. And so that is the amount of bacteria present. We'll say amount of bacteria present at the end of the time. And the t here is the time. And it's in days. So it's days since the antibiotic was introduced. So if I want to find how much antibiotic is present 5 days later, well then what I'm going to do is I'm going to take my function and I'm going to substitute in 5 for t. So in place of t, I'm going to put 5. And then I'm going to put this in the calculator. Make sure if you're doing this in pieces that you do not take the 1 million times 2 first. In the calculator, you can put it all in here and you can put the exponent. The calculator knows to do the exponent first. But if you're doing it in pieces, do not multiply the 1 million by the 2 first and then take the exponent. You want to do the exponent first, the base of 2 exponent first, and then multiply by 1 million. So what I was saying was you could put it all in the calculator like this. And you have to make sure that you put in 6 zeros. And now I'm going to put negative 5 divided by 20. Now, if my calculator superscripts like this, then I can just write it like that. If it doesn't, it puts that actual caret symbol in, and there, stay on the bottom line. Then I have to surround this exponent with parentheses. When I hit enter, I get my answer. And so it says surround to the nearest 1,000, not thousand, but 1,000. So my answer here would end up being, well, first let me write out the number that's on the calculator screen. And then if I want to round to the 1,000 place, that is here. And so I look 1 over. Now we're used to rounding numbers in the decimal area, but now we are going to round here. And because that is 8, this 8 is 5 or more, I'm going to take that 0, I'm going to round it up to 1. And then anything to the right until you get to the decimal place, I will replace with zeros. So we have this many bacteria present after 5 days. Now we'll try the next one. Now, again, I'm going to write the function, and I'm going to leave a blank spot wherever I had a t. And now I'm going to put in the time. Well, should I put in 1 week? Should I put the number 1 in? No, I have to have the time in the units of days. So I know in 1 week, there are 7 days. So I'm going to put in 7 instead. And so let's put this on the calculator. Now, if you have, let's go back to the other calculator. I'll show you a shortcut. So, let's put in the problem, and then I'll show you the shortcut for the next problem. So I'm going to put in 1 million. So counting, I've got 6 zeros there. And then I'm going to hit 2. And I can put a time sign or parenthesis. and then caret symbol, -7 over 20. Right arrow over will get me back to a regular line, and I can close the parenthesis. So I end up with this value. And again, it wants me to round it to the nearest 1,000. So here's my answer that I got on the calculator. And so rounding it to the nearest 1,000 would be this place. And because this is 5 or more, we're going to round the place with the arrow up. And my answer should be 785,000 bacteria. And so we see that in 2 additional days, the bacteria count has gone down with the antibiotic. So that's a good way. We want it to go down. Now the last one says 3 weeks. So 3 weeks, I'm going to use the conversion factor that's up above, and I'm going to say, well, I want to get rid of weeks, and I want to go to days. So 3 times 7 is 21. The weeks cancel out, and it'll be 21 days. 3 weeks is equivalent to 21 days. I have to put it in terms of days in order to properly use the formula. So I'm going to write down my equation, my function, and I'm going to, in place of the t value, I'm going to put in 21. And then put it in the calculator. Now I mentioned that there's a shortcut. And so the shortcut is that if I want to re-enter all of this previous information, I can just hit second enter. And it will give me the prior entry. 1 million's already there. The 2's already there. I'm just going to change this to 21. Now I know there's not a digit there, so I'm going to hit second delete so that I can insert. And so here's my answer for part C. And I also need to round this one. So to the nearest 1,000 would be 483,000. So I'm going to round here, look 1 over, and because that's a 9, I'm going to go up to 3. And this would be the number of bacteria left after 21 days. All right, and then there's one more problem, and it's at the bottom of the page here. And it says the amount of radioactive material present at T days is given by this function, where A sub 0 is the amount that was initially present at T0, and H is the material's half-life. So this is the formula. We had it on our paper earlier. And the pieces of this formula, let's talk about what all these different pieces mean. This right here will be the future amount. A sub 0, when you typically have A or any letter with A sub 0, what it means is the initial amount. And then we've got lowercase t here. This is the time, and that's in days. And then we have a H here, and that H stands for half-life. So now we know all the pieces of this equation. So I'm going to use that information now to help me solve. And it says how many grams are present, that should say present, 60 days later. So I want to know the future amount. So a lot of times what I will do is I will put all the variables off to the side so that I can fill them in. I'm interested in the future amount. It says, but in order to do that, I need to find the initial amount. It says if 5 grams of arsenic 74 are present. So this is the starting amount, 5 grams. The time is, let's see, 60 days later. So we want to know what happens after 60 days. And the half-life is 17.5 days. And that's given to us in the problem. So let's plug everything in besides the A, because we don't know A yet. That's what we're looking for. And I have to make sure that I put these exponents in the right order. 60 is the time and 17.5 days is the half-life. And so now when I put this in my calculator, let's see what I get. Now I don't have to surround the exponent with parentheses, but you could, if you want to get in that habit. It's a good habit to have. But if you do have a caret symbol that shows up, then you have to surround it with parentheses. So I end up with 0.64 if I'm going to round to 3 decimal places, and that's how much is present after 60 days. So the future amount will be 0.464 grams. It starts with 5 grams, and now it's under 1 gram. So because the half-life of arsenic, 17.5 days, so it starts to decay, and it will be half its original value after 17.5 days, and then another 17.5 days passes by, and there'll be half of the previous value. So you keep going down, 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 down.